Okay, Chapter 8. We are looking at confidence intervals for a one population mean. So we'll talk a little bit about what I mean by a confidence interval here. We get into this section, but a one population mean is we're really only looking for the population mean for one variable. We're looking at simple cases here. So we're going to this first section 8.1, we're going to get into some definitions here and start going about how do we estimate what this population mean is. So we're really finally getting into this idea of inferential statistics. We've been doing a lot of descriptive statistics at this point and developing up the tools we're going to need to make this prediction. Because our goal is we have this population, we are going to try to figure out what the population mean is, mu, by using our sample. Because, as again, we've said many times, censuses are wonderful for describing a population, but we generally can't do that. And we know when we're using a sample mean, we will get sampling error. So we can't necessarily say x bar does equal mu. So what we are going to look at, what we call is a confidence interval. We're basically saying if we estimate the population mean, if we estimate mu from this given sample, how close are we? And that's what we mean with, within this boundary, it's somewhere in this range of values. That's going to be what we mean by our confidence interval. So just kind of a quick overview of what we're going to do with this unit is we're going to first define out what confidence intervals are. We're going to calculate the confidence interval when we know what the standard deviation is for the population. And then, how often do we know that? Well, sometimes we know it, sometimes we can get pretty close. If we don't, we're going to learn a new distribution called the t-distribution that helps us find this confidence interval for the one population mean if I don't know what the standard deviation of the population is. So this is getting us into predicting. Again, we're using our sample to predict something about the population. We're focusing on the population mean here. So, as I say, very often we are trying to find that mean value, that center. That average is as we sometimes want to call it. We want to find mu. And when it's small, we just collect all the population data, do the census. When it's not, we take a sample and we use the sample mean, the x bar. When we use x bar, we take a sample to estimate the mean. We call that a point estimate. And it's going to be, we need to get down to what is this value, our single number, a single point. So the point estimate, pop up again. Of the parameter, it's the value of the statistic. So again, statistic comes from a sample. Parameter is describing the population. So we're taking that descriptive statistic that we're using to estimate the value of the related parameter. Getting all this lovely vocabulary back and forth. So here's a set of data. We got 36 new mobile homes at these prices. These prices are all in thousands of dollars. We want to predict what is the mean price of a new mobile home. So we're looking again for that population mu. If I'm going to buy a mobile home, what do I expect to pay? So we can do this, add them all up, divide by 36, we get 63.28 is going to be my mean value, my sample mean from these 36 that we tried. So based on the sample data, we estimate the mean price of all new mobile homes is approximately $63,280. how good is it, right? So again, some vocabulary with this. The statistic is called an unbiased estimator of a parameter if the mean of all its possible values equals the parameter. So that's what we were looking at in chapter 7, where we looked at that mu sub x bar. What's the mean of all of the means, of all the sample means? And if the mu sub x bar equals mu, this is called an unbiased estimator. And if it's not true, if the mean of all the samples does not equal the population mean, it's called a biased estimator, which means it's going to affect, where it's going to be. If it's an unbiased estimator and a small sample error, chances are pretty good that our point estimate is going to be close to the parameter. So that's kind of what we're putting together what we've been working on in the past couple sections. So, and we're going to do that with this idea, gets us to what the confidence interval to tell us how accurate our point estimate is going to be. So we're going to start with, we're looking at that mean price again. We know in this case that the standard deviation for mobile home prices is $7,200. So that gives us a sigma of 7.2. It's always nice if we have this. So we're going to identify the distribution of the variable x bar of the sample mean. We're going to show that approximately 95% of all of the samples of 36 new mobile homes are going to have the property there. The interval from my mean plus or minus at 2.4 is going to contain the actual population mean. And then we're going to find a 95% confidence interval, which means an interval of numbers that we are 95% confident that it contains mu. So, the distribution. We have 36, so we're relatively large. So we can assume x bar is normally distributed by the central limit theorem. We looked at that last section. So mu sub x equals mu, and sigma sub x bar is just sigma over square root of n, which in this case would be 7.2 over the square root of 36, or 1.2. So for the sample size of 36, we can say x bar is normally distributed with a mean of mu and the standard deviation of 1.2. So we go back to that empirical rule that said, hey, 95% of the data for a normal distribution, 95% of the data will be within 2 standard deviations of the mean. So if the standard deviation we said was 1.2, 2 standard deviations is 2.4. So if we take our sample and we go 2.4 above, 2.4 below, we say approximately 95% of all these samples will contain mu. So that's kind of where we're going here. So our confidence interval is we're just going to do that. We're going to take x bar plus 24, x bar minus 24, or 2.4. So we get 60.88 to 65.68. That says we can be 95% confident that the mean price of all new mobile homes is somewhere between $60,880 and $65,680. we're not necessarily saying it's a 95% probability it's in there. We are 95% confidence that the mean price will fall in that range of value. It's kind of more vagueness on top of vagueness. But it's the way we don't nail anything down. So we're 95% confident, that's how positive we are, that it's somewhere in that range of values. So, again, the confidence interval is the interval of numbers from a point estimate. So that's going to be in that last problem. That was our 60,880 to 65,680. That was our confidence interval. The interval of numbers that we're going to use to kind of help estimate that parameter. The confidence level is how confident are we that this interval I gave actually has the value of mu in it somewhere. Now the confidence interval estimate, we put together the confidence level and the confidence interval. So our point estimate says this one again, let's go back again. Wrong way. Our point estimate is we estimate that the average value is 63,280. Our confidence interval says, hey, it probably isn't that, but it's close, and I'm 95% confident that it's between 60,000 and 65,000, on there. That's kind of what we're saying here. So when we say here, it depends on the sample mean, which depends on the sample. You take a different sample, as it says. Different sample, you're going to get a different confidence interval. We're giving a range that could contain mu. But there's other ranges that contain mu, and it does not necessarily have to say mu. So, for example, if we're going to take this and pull this from the book, they did a computer analysis and a simulation on that. But if we assume that mu actually is 65,000, and this is going to look at 25 different samples of 36 homes, and that gives you this. Here are your 25 samples. These are your 95% confidence intervals for each one, and your sample based on the sample. You notice all of these with the 95% confidence interval, and that your standard deviation is the same, so that 95% confidence interval, all of these bars are the same width. All of these intervals have the same range, but they're kind of moved by where the sample mean is. You see, here's my 65. Most of these samples do contain mu. We're 95% confident our sample, our confidence interval is going to contain mu. And most of the time, out of these 25, 24 of them do. But here's one sample that doesn't. Here's one that almost pops up. There's a few of these that are kind of extreme on this case. Here's going the other way. So most of them contain mu. Not all of them contain mu. That's one of the things with these confidence intervals. We're still saying, I don't know what it is, but I'm pretty confident it's somewhere around here. Hedging our bets, yep. So we also talk about our margin of error. One way is to say, here's the confidence interval. The other is to say, this is my point estimate, and this is how much error I think I can have. Because we got our interval by taking the point estimate, adding and subtracting this 2.4. So we could refer to this as 63.828, that's my point estimate, plus or minus 2.4. This would be our error. So we would call 2.4 our margin of error. So the range of data between the 60.88, 65.68 is actually going to be 4.8. But the margin of error is 2.4. It's half of that because we're going off of my point estimate. 2.4 either way, we got that little leeway. So here are some problems for you to explore.